Welcome back to Chips and Salsa, where we talk security at Intel, and I'm excited to have Anand Pashupathi here today to talk about the 2026 Intel Platform Security Report. Anand is the General Manager and Vice President of Intel Product Assurance and Security, and also the owner of the Product Security and Confidential Computing Roadmaps. Anand, welcome. Nice to have you back on the show.
Thank you, Jerry, for inviting me back. I must have done pretty good last time that you had me back now again. It's good to be here.
Always good to get your valuable insights, and let's just jump into this. So what is the 2026 Intel Platform Security Report, and why did we create it?
Sure. For people who are not aware, the 2026 Intel Platform Security Report is our annual data-driven look at how Intel platforms perform from a security perspective. And we created it for technology decision makers who are asking very simple questions. And I would articulate it in the following way. How secure is the silicon foundation I'm betting my business on? How does it compare to alternatives in the market? And are my vendors really investing ahead of the next wave of threats like AI, post-quantum, advanced attackers, et cetera? And I'm very proud to say that this year's report, Jerry, goes beyond just the vulnerability count. It shows how Intel embeds security into our architectures, our development lifecycle, and our supply chain, and it backs that up with independent benchmarks, third-party validation, and competitive data. And the goal is to give executives the confidence that their security strategy is grounded in a trustworthy hardware platform.
Nice. So what's different in the 2026 report versus previous years?
I love the number 3, so I'm going to give you 3 reasons that stand out for me. Confidential AI has become a first-class topic, and that's number 1 on my list. And we go deep on how Intel TDX, or Trust Domain Extensions, and our confidential computing portfolio protect AI workloads, the models, the data, the prompts, across training, fine-tuning, and inferencing, in the cloud, in sovereign areas, and on-prem environments. That's number 1. The second one is post-quantum readiness in real products, not just roadmaps or marketing collateral. And we highlight that Intel is the first CPU vendor implementing post-quantum ready cryptography in shipping platforms. And we describe how we already have addressed threats such as harvest now, decrypt later in our platforms. And the last one is providing that assurance of hardware-enforced software robustness and memory safety. We showcase technologies like control flow enforcement technology, or CET, and upcoming memory tagging capabilities on our platform that are designed to mitigate classes of software vulnerabilities in hardware. So the 2026 report is less about here is what has happened last year, and more about here is the hardware security foundation you'll need for AI-driven and quantum-impacted environments over the next decade or so.
So if you had to boil it down, what are the top 2 or 3 takeaways customers should walk away with?
Not surprisingly, I'm going to give you 3. I'm going to highlight 3 for you. The first one is hardware is now the security strategy. It's not an implementation detail. And I say this because this report will show you how Intel platforms provide a hardware-rooted chain of trust that extends from silicon through firmware into the OS, into the workload. So that's number 1.
Yep.
The second thing is that Intel's security position is both measurable and differentiated. We shared independent assessments that rank Intel's product security assurance at the top of the silicon industry. And we include vulnerability data that demonstrates consistently fewer platform and firmware vulnerabilities than key competitors, and especially in the confidential computing and root of trust firmware. And the last one is we're investing ahead of the threat curve. From confidential AI to post-quantum cryptography and memory safety, we're not just reaching to mitigate CVEs. We're building capabilities that are meant to withstand where the adversaries are going. So where the puck is going, not just where it's been. And for customers, the implication is very simple. Choosing Intel isn't just about performance or power. It's about putting your AI and mission control or mission critical workloads on a platform engineered to be the foundation of trust and secure from the get-go.
So AI is top of mind for most executives right now. So how does the report address the security of AI workloads?
Yeah. We dedicate an entire section on confidential AI, which to me is really at the intersection of confidential computing and artificial intelligence, because AI fundamentally changes the risk profile. And whether you're processing a highly sensitive data, be it patient records, financial transactions, proprietary IP, your models are also your valuable assets, and adversaries are starting to go after these models. Model theft is becoming a big deal. Data extraction and prompt injection are these attacks that are happening in the AI world. And these workloads are increasingly getting distributed across cloud, edge, hybrid environments. And this report will explain to you how Intel's confidential computing technologies, especially Intel TDX, create hardware-based trusted execution environments that, be surprised, three things: encrypt memory and isolate workloads from the hypervisor, cloud provider, and other tenants as well. Provide remote attestation so you can prove to the auditors and regulators where and how your AI is running. And lastly, extend protection beyond the CPU with TDX Connect based on the TDIS protocol, which secures I/O to GPUs, smart NICs, storage, and other PCI Gen 6 devices, enabling high-performance AI while keeping data encrypted in transit between these devices. So the message to customers really is very simple. You don't have to choose between AI innovation and risk. With the right hardware foundation, you can actually have both.
Awesome. So let's talk a little bit about post-quantum cryptography. This can feel kind of abstracted and far away. Why does it feature so prominently in the report?
Yeah, people have been talking about post-quantum as a very futuristic-looking problem, but for many organizations, it's actually a now problem, not a future problem. Data you encrypt today may need to remain confidential for the next 10, 20 or more years. Adversaries are already following, hey, let me go harvest this data now, and I'll decrypt later when there are systems available for me to decrypt it, quantum capabilities like systems. And we feature PQC prominently because hardware is where the transition becomes real. We are integrating post-quantum ready algorithms into firmware signing, microcode authentication, and attestation flows on our latest platforms. We're deeply involved in industry PQC standardization, and I've actually helped define signature schemes that will be broadly used across the industry. And our roadmap targets having quantum-resistant protections are in place for all of our new platforms by 2030, aligning with government and regulatory and industry guidance. For an executive audience, the key point really is transitioning to quantum-safe cryptography will be a multi-year journey. The safest path is to choose a silicon partner that is already building PQC into their foundation, into their platform now.
Let's transition to talk about hardware-enforced software robustness. What does that actually mean, and why should customers care?
Yeah. The reality is most high-impact attacks still exploit software bugs. Buffer overflows, use after free, control flow hijacking, etc. And when we say hardware-enforced software robustness, we're talking about technologies like control flow enforcement technology, like I said, we fondly know it as CET, to prevent return-oriented programming and certain classes of code reuse attacks. Hardware mechanisms to strictly separate user and kernel memory spaces, reducing the blast radius of a compromise. And lastly, memory tagging capabilities are starting to emerge that can detect illegal memory accesses at the hardware level, catching bugs that today would lead to remote code execution in the future.
Yeah, so when we talk about software robustness, what problem are we actually trying to solve?
Right. Look, at the end of the day, we all have to accept a hard truth that software robustness is trying to tackle an inevitable problem of having bugs in software. Okay, so once you accept that, even with modern development practices, memory safety issues still account for a majority of high severity real-world exploits. And robustness means designing systems so that when these bugs do occur, they don't automatically become security vulnerabilities. Instead of relying on a single defense, we layer protection so failures are contained and exploitation becomes extremely difficult. This is the software robustness defense in depth stack. For customers, this matters because it's one of the few levers that they can fundamentally use to alter the software risk profile. You can patch faster and segment networks, but if your underlying platform can prevent whole categories of exploits from working reliably, that's a structural advantage that you're getting.
Most definitely. So here's a challenging one. So the report makes some very strong claims about Intel's security leadership. How do we back those up?
Yeah. Look, we have consciously moved over the last few years from just making marketing claims to measurable, auditable evidence. That's what we are focusing on. Independent assessments rank Intel's product security assurances practices at the top of the silicon industry. We include year-over-year vulnerability data that compares Intel to other CPU vendors, broken down by categories of platform firmware, confidential computing firmware, root of trust components, and more. We call out that 96% of vulnerabilities we address are found through our own proactive security assurance program. And the vast majority of the vulnerabilities found in Intel hardware are found by, guess who? Intel engineers. Our teams are just simply relentless about this. We also highlight not just the work we're doing internally, but also with external researchers and partners. Collaborations with groups like Google's cloud security team, the Microsoft offensive security teams, to stress test technologies like Intel TDX based on their expertise and usage as a hyperscaler, because that's where TDX is going through its immediate journey right now. And for customers, this isn't about vendor bashing. It's really about demonstrating that a hardware partner like Intel takes security seriously enough to measure it, publish it, we're transparent about it, and hold ourselves accountable for continuous improvement year after year in a very transparent way. And that's what this report is about.
Yeah, so you kind of alluded to how we find a lot of these issues ourselves. So let's talk a little bit about that, the internal security processes. Sure. and what's behind the numbers. Sure. In the report.
Sure. So the report is showcasing a lot of hard work that goes in, and it's a very deliberate transformation in how we build silicon and platforms. A mature, secure development lifecycle that embeds threat modeling, formal verification, negative space testing throughout every phase of the product development. The SDL operates as a closed-loop system, enabling proactive identification and remediation of issues while helping to ensure fixes are applied consistently across all potentially impacted platforms, not just on one platform. So that's huge. The second thing is we have a dedicated offensive security team whose job is to find these kinds of issues that real-world attackers would go after across RTL or design code, firmware, and platform architecture. And our offensive security researchers have a combined 1,000 years of experience and are redefining the entire silicon security assurance and verification landscape with precision, creativity, and unmatched technical depth. For example, this INT31 shirt that you and I are wearing, This is how our internal researchers are publishing their external work. So I'm very happy that we're sitting here wearing this and talking about security researchers. There is one outcome that I want to highlight in the report, is that it's significant 80% reduction in security escapes in product release since 2019. 80%. And that means fewer surprises post-launch, fewer emergency patch cycles, and more predictable risk for enterprises. And the message to executives is, you're not just buying a chip from Intel. You're buying into a development culture that treats security as a first-order design parameter, not an afterthought.
Yeah, that's a strong number, 80%.
Yep.
That's a true sign of a mature SDL
Yep.
program. So what's your advice to customers who want to turn the insights from this report into action?
I'd offer 3 concrete steps for them. The first one is make hardware a formal part of your security architecture. Treat your choice of client and server platform as a security decision, not just an IT procurement decision, i.e. cost. Look for hardware-rooted protections, confidential computing capabilities, and clear post-quantum implementable roadmaps, not just marketing roadmaps, but implementable roadmaps. And use independent data in vendor evaluation. This will be my second advice to them. Don't rely solely on claims. Ask for vulnerability data, third-party assessments, clear security development practices from all of your silicon and platform vendors, and query them about the maturity levels of these programs, because that really matters, as I've shown you through our own maturity. And lastly, plan for AI and post-quantum together. Your AI strategy and your quantum safety strategy both depend on the same foundation, the platform. Make sure the systems that deploy over the next 3 to 5 years can support confidential AI and are on a path to quantum-safe cryptography. The broader message is, this report is not just a scorecard for Intel. It's a toolkit for you to ask better questions and raise the bar for every technology provider in your stack. That's what we are hoping this report is able to do for our customers and our partners.
Awesome. So you have been working in security for quite a while. What excites you most about where platform security is headed?
And you must be wondering, man, this guy's very energetic about security. He must have had a lot of coffee today. Actually, no, I'm just excited about security because, and the reason I'm excited about it is I finally see it move from being a constraint to an enabler, or oh my gosh, I got to take off security, to, hey, security will actually help us win more business if we do it right. And confidential computing is letting organizations use data they were too afraid to touch before. Post-quantum work is forcing us to rethink cryptography in a way that will make the entire ecosystem more robust. And hardware-enforced protections are taking some of the burden of developers and defenders who have been asked to do the impossible for too long. Again, you don't have to choose between innovation and risk. With the right hardware foundation, you can have both.
Well, Anand, thank you for your time and your valuable insights. For our viewers who want to find out more, the 2026 Intel Platform Security Report can be found at intel.com/security report. And thank you again, Anand, and thank you for watching.
Thank you for having me, Jerry. Pleasure.